Ladies and gentlemen, welcome to the last event of the Sustainable Powertrain Tour 2022. Biomethane, the right way for decarbonization and a springboard to accelerate the transition to hydrogen. Okay, let me say a few words just to clarify. It won't only be biomethane under the spotlight in this session. The real target we want to hit are the new internal combustion engine ACEs. So, can hydrogen and e-fuels, HVO and biofuels contribute to the redemption of the internal combustion engine and support the energy transition? Because, Maria Grazia, there is no transition that is not step by step, isn't it?
That's right, Fabio. Let me introduce myself. I'm Maria Grazia Gargioni and I'm involved both in diesel international.com and in the bi-monthly magazine Powertrain. Let's start with the schedule. Fausto Elementi, Strategic Sourcing and Supplier Quality Director at NGV Powertrain, will break the ice with an overview of alternative fuels. Andrea Ba, on-road product portfolio and marketing at FPT Industrial, will tell us about its field experience with biomethane. Jamie Fox, Principal Analyst at Interact Analysis, will tell us about his views on the hydrogen ecosystem. He's followed by Jim Nebergold, General Manager, Hydrogen Engines at Cummins, the company that has invested the most in the entire hydrogen chain, from production to consumption. Roberto Golisano, Senior Program Manager and Chief Engineer, Hydrogen Engines Programs in Punch Hydrocells, will bring us the mechanical expertise inherited from GM Powertrain, coupled with the electronic and the hydrogen skills of the Punch Group.
Okay, thank you, Ragazza. Take a breath. It was a long introduction. And thanks in advance to all the speakers. The topic is a hot one, really hot one. Cummins and FPT Industrial themselves showed hydrogen engines at the IAA, as did Weichai, the only 3 engine makers to show at Hanover. And even at Bauma Munich, we saw an explosion of proposals, including Kubota's one, just to make an example, and some hydrogen genset applications. This is why we ask you to respect the timing, 10 minutes for the NGV and Interact Analysis overviews, 5 minutes for the panelist speeches, 3 minutes for the answers. So I give the floor to Fausto Elementi of NGV Powertrain. Please, Fausto.
Hello to everybody. Good afternoon. I'm really pleased to be part of this very important webinar. Okay, just a quick introduction, as indicated, is just to explain a little bit what we are doing, which is the NGV view and overview about the new fuels. So it's clear that okay, just a quick introduction. That is clear that the carbon neutrality, it's clear, is unavoidable. And this is something that it's important to understand that in this period we will need to take decisions that are critical decisions, and since are critical decisions for the next few years, and also for the futures of for our business, and also for the environmental, it's very important to not take emotional decisions. Just a quick overview about what we do as a NGV. Okay, as some of you knows, cooperating with FPT and other key suppliers, we are an innovative startup currently developing and producing ICE engines with alternative fuel. And the target is, it's clear that is to have a low to zero CO2 emission. Our company missions can be summarized in somehow, and I think that is important at this point, that it can be summarized in 3 points. So emission-free, and emission-free means also the abatement of the local pollutant, because sometimes emission-free is felt that you are not having emissions in one area, but you have other emissions in other areas. So it's important also to have a local pollutant close to zero. Sustainability, It means that for us is, of course, a circular economy, but also the reduction of investment, because our technology can be used also if it's sustainable in terms of investment, and of course also affordability. So not also suitable for low-cost countries or developing zones. Of course, we are a startup, so we are open to any kind of solutions. We are not, for us, Powertrain, of course, is Powertrain, but really we think that, and we strongly believe that IC that is sometimes felt like the evil, so something that we need to get rid as soon as possible, actually is not true. Now is felt like kind of bridge, something like that, okay, old economy, bridge to new economy where no more engines, no more, or almost no more engines. We do believe that this is not true, because anyway, IC is in the proper usage with the alternative sustainable fuel, biomethane, bioethanol, hydrogen, e-fuel is actually not only a bridge, but will be a solution for the future economy. Just a very quick just introduction about the H2. Of course, later on, some other panelists will go much more in details. We are, of course, more than interested, and we are already working in some pilot projects in H2. We do think that it's ICE is it's one of the key system to transform the energy that is stored in the H2 to electrical, mechanical, and eventually electrical power. It's clear that all the time when we talk about H2, there are, let's say, two worlds, two religions. One is a fuel cell, and the other one is IC. And it's clear that if we check just only the number, the fuel cell, as they have higher performance. But we have to consider that in case that IC is used as a range standard, and actually the fuel cell are used as a range standard, because anyway, fuel cell, for example, for the transportation, it can be, let's say, only used together with some batteries. So basically, it's just a step. It's not the real final, let's say, production of the energy. If we consider IC as a range extender, so limited displacement and power, a stable state, how can I say, the performance, the efficiency, and also the pollutant are quite comparable to a best fuel cell, but we have to consider that the cost is 1/10. So at the end, we think that IC will play also a big role, not only on with alternative fuel, alcohol, bioethanol, but also in H2. But this is the future. We have to consider now what we can do yesterday, now, and tomorrow in order to reach the real sustainable economy. And our approach is clear that we are working already with engines with bioethanol and biomethane, and this one are, let's say, our let's say, key role. We are playing a key role, and this one is our key products. It's clear that where we are using this kind of engine, for example, this one case clear that we know that electrical mobility it will be the future, but we have to consider this one. I think is an interesting example that let's say electrical car, in principle, if the electricity is produced with no impact in the, CO2 production, are perfect. in fact, there is a little issues because anyway, in order to have the real mobility, we needed to have some fasting charging displaced all around, and also especially in the remote areas. For example, this one is one area where we are investing and we are playing a key role using our engine as a off-the-grid charging stations. In this case, so basically we are overcoming the typical issues related to the fact that a fast charging station needs a peak of energy and after a quick drop that is difficult to be managed by the normal grid, but it's quite easy to manage by bioethanol or methanol or biomethane. And also this one is a very good idea because basically at the end we are using the existing excellence, existing knowledge. So basically also in terms of investment, in terms of, I will say, production is limited. And together with that, we have to, it's clear that, okay, in this case, we are using bio or fluids that are actually with zero impact in CO2 productions. Of course, it's clear that ethanol, methanol, and biomethane should be produced by means of material that are already available and without the impact on let's say let's say what is called not feedstock biomass. Otherwise, it's clear that in one case we are not, let's say, we are net zero, but on the other side we are impacting. And for example, that's the typical example is the biomethane that can be produced also using the syngas that is produced by solid part of the organic waste, so at the end, waste. So at the end, there is a zero impact on CO2 production.
Thank you very much.
Okay, thank you so much.
Did you have finish?
Just if I can put just a couple of topics, very fast. What we think that, okay, this one is clear that we have a good, really good impact on the supply chain, on excellence of the existing suppliers, and our, let's say, our point of view and our conclusions that are the power solution for the future will be a mix of different solutions. And for sure, IC will play an important role in the transition and also in the consolidation of in the future. That's pretty much my point.
Okay, thank you.
Thank you very much, Fausto, for broadening the horizon to include alcohols. Now let's get to the heart of biomethane with those who are pioneers and supporters of this technology. I mean FPT Industrial. Please, Mr. Andrea Abba.
Hello, good afternoon, everyone. So just a brief introduction of FPT Industrial. FPT is a brand of Iveco Group that design, produce, and sell powertrain for on-road, off-road, power generation, and marine applications, with over 8,000 employees in 11 production sites and 11 R&D centers worldwide. As FPT Industrial, we have always been committed to sustainability. That means design and produce sustainable engines, but also have attention to sustainable process and all the value chain. This strategy is envisioned in a multi-energy approach. The switch from a carbon-based economy to a carbon-neutral economy is probably the biggest challenge that we have in front of us in our industry, both for on-road and off-road applications. So FPT is fully committed to reach the net zero emission by 2040. but we cannot reduce the CO2 emission just switching off the engines, because we have to respond to two different demands. From one side, we have to design and produce new and greener powertrain products, but from the other side, we have also to continue to support and satisfy strategic sectors like agriculture and transport that rely on our current product lineup. So this is the reason why we are working on different technological paths with a different energy carrier, like renewable fuels, e-fuels, biomethane, and hydrogen. Talking about natural gas, we have been the first to introduce natural gas engines in on-road segments. And today in Europe, we are a market leader with more than 50% of market share. In the last 25 years, we sold more than 70,000 natural gas engines, leveraging on the widest lineup on the market, from 2.8 to 13-liter engines, from 50 to 460 horsepower, covering from light to medium and heavy commercial vehicles, buses, and also some off-road applications. We started to introduce natural gas products for on-road segments, and in the recent years, we extend these products also to off-road, where it can represent a short-term answer to CO2 reduction, enabling circular, self-sustainable, and net zero economy, leveraging on biomethane that can be produced directly from anaerobic digestion of agricultural feedstocks. 10% of CO2 reduction can be achieved with natural gas from fossil fuel, but a net zero can be achieved with biomethane, or even negative CO2 emission using manure. Some example of real application of biomethane with our products. The first one is the methane tractor developed with the CNH Industrial, with our new NEF 67 that run in farms that can produce by themselves the biomethane. The second one is the prototype that is running in Fontana Fredda with our F28 natural gas for grapes of barrel wine. And the third one is the net zero power generation from biomethane in collaboration with Bennamann. Moving to the hydrogen, hydrogen for sure is the next challenge, strongly subject to infrastructure and value chain development. On this path, we are working on two mainstream. One is the hydrogen internal combustion engine that allows an easier integration on conventional and current vehicle platform. And we are working on this technology leveraging on our long time experience on natural gas. And the second part is the fuel cell that for sure allows a higher efficiency, but requires a full electrification of the vehicles. So thanks to a longer autonomy compared to full battery electric vehicles, the fuel cell would be the preferred solution for heavy-duty application in the long-term scenario. Talking about real application also in this case, we presented our new X-Cursor 13 recently at IAA in Hanover and also at Fenatran in Brazil. The XC13 is our first multi-fuel single base engine that run diesel, natural gas, and hydrogen to fit different market, different emission requirements. It will be the major contributor to reduce the CO2 reduction for 2025 for Iveco Group. And after just 1 week from the presentation at IAA, we presented together with our partner, Prinot, the first world prototype of snow groover with our XC13 hydrogen combustion engine. So this is a clear example of our commitment into hydrogen, but we have also other examples. We develop together with Landi Renzo, another partner that we have on the market, we developed the ethane onboard blending system to mix hydrogen and methane. Thanks to a dedicated dual-rail system and a dedicated control system, this technology can reduce the CO2 emission up to 10% versus natural gas and 20% versus diesel, using the same natural gas engine layout and delivering same natural gas performance and efficiency. So these are all our commitment for both biomethane and hydrogen combustion engines.
Very, very, very good, Andrea. So we remain to FPT industry, but before, let me remember you what's the pattern in few words of our webinar. So we like mixing the different profiles in general, such as philosophy, in particular, talking about the decarbonization path. We think is very, very wise to mix, for instance, profiles such as Cummins, okay, the most important engine manufacturer and technology manufacturers in the world. It's the same for a big engine manufacturer such as FPT Industrial, an engineering group like the Belgian group Punch, and a startup like NGV. So anyway, now, Andrea, in 3 minutes, focusing on Europe, can you reply to this question? Is it, we talk about Repower Europe, we like understand more about this, these laws, these rules, and do you think that there is really an opportunity after the approval of 455 program? Please, Andrea.
Yes, the revision of the CO2 emission standard regulation for heavy-duty vehicles is for sure an opportunity to guarantee the sustainability of the European freight road transport, promoting the investments in alternative fuels like biomethane. A technology open regulation for CO2 emission is recognizing the contribution of sustainable renewable fuels will enable an holistic European climate policy combining ambition with efficiency. In 2021 has seen an impressive increase in biomethane plants, more than 1,000 new plants introduced and opened, and some European member states already today have a very high rate of biomethane in their on-road transport. Finland more than 50% and Sweden more than 95%, with positive effect for CO2 reduction and for fuel price at pump. A prerequisite for the development of new alternative fuel vehicles is the availability of alternative energy carrier and the availability of their related infrastructure. So we are happy to see that the European Commission recognize the role of renewable fuels and biomethane in particular with the Repower EU, but larger volumes of biomethane are not enough without an adequate policy and infrastructure framework, enabling the transport operator to benefit from its usage.
Thank you, Andrea. Now, Interact Analysis is a British consulting company that has supported us on several other circumstances and events. We thank them for having renewed their trust in us and give them the floor, knowing that they are often a critical and scrupulous voice of the dynamics of alternative propulsion. You are talking to us about hydrogen, aren't you, Jamie Fox?
Please, Jamie.
Hi, everyone. So today I'm going to talk about hydrogen. Now, when people think of hydrogen, they tend to think of fuel cell. but I'm going to be talking about something a little bit different today, hydrogen internal combustion engines. And I'm going to be sharing some findings from the report that we published on this topic, the first report that we've published on hydrogen engines, which we've just published this month. Now, the pitch for this technology is pretty simple. Low NOx, carbon neutral, fast refueling, takes advantage of existing engine technology, and the vehicles are less expensive than battery electric or fuel cell. So that's the pitch, but I'm going to talk in more detail about how that stacks up to the reality, and that will be the topic of this presentation. Now, before I do that, I would like to just do a quick introduction to our company for those of you who are not too familiar with us. So we have 30 staff members, mostly in the US, the UK and China, although I'm based myself in Chile. We are mostly higher experienced analysts with a lot of industry experience or experience as an analyst. We focus on quality, so we're towards the higher end of the market research market. And our reports have a lot of quantitative data in most cases, although our report on hydrogen is a little bit more qualitative, just because hydrogen engines are really at the beginning of the road, and it's quite early days to do a very detailed quantitative study. Our reports have, we tend to pride ourselves on access to analysts, so it's fine to buy our reports and then spend several hours of follow-up with the analysts from the report, and we're very accommodating with that. Now, I myself have got 16 years of experience as an analyst, and I've been working in commercial vehicles specifically since 2020. So I've mostly been covering on-road so far, but now I'm also starting to cover off-road a little bit, which I'll also do more of next year. I've mostly focused on alternative and zero emissions technologies, so electrification mostly, of course battery electric and hydrogen. So how does the pitch that I shared compare to the reality? So the pros of hydrogen engine vehicles are a familiar engine. So it's relatively easy to produce that engine with the same people, the same factory that you've already got for some companies. The cost of the engine is reasonable. There's a high power. There's a good energy density compared to battery electric, and also faster refueling compared to battery electric vehicles. On the other hand, the running costs of the vehicle is high, and the total cost of ownership overall is not great compared to diesel and battery electric in most cases. And the running cost is high because hydrogen is expensive, and as I'll talk a little bit more later, it's also fairly inefficient, at least compared to a fuel cell or battery electric, to use a hydrogen engine vehicle. So you also need, of course, the infrastructure, hydrogen infrastructure, and you can't get NOx all the way to zero. So that's a general comparison of the pros and cons. I'd also like to do it again, but this time comparing hydrogen engines specifically to fuel cells. Now, first of all, in the case of hydrogen engine, we see a lower capex, so the vehicle cost itself is lower than a fuel cell. There's a higher tolerance to fuel impurities. There's a flexibility to switch between fuels. There's the reduction of rare materials, and there's familiarity in that, it's a familiar vehicle if you're used to engines and how to produce a vehicle with an engine. On the other hand, the main disadvantage really is the lower efficiency of a hydrogen engine. And that lower efficiency means that the fuel cost is higher. It means that the environmental impact is higher. And it means that there's more tanks are required, which takes up more space, and also means more weight. And noisier, of course, than a quiet fuel cell. And a hydrogen engine will also produce some NOx. You can't get it all the way to zero. And also, I think a problem for hydrogen engines in practice is that they're not very well known yet. People tend to think of fuel cell when they think of hydrogen. So there's kind of a marketing problem with getting the technology going for now. Of course, it's early days. That may change later. So overall, to summarize just the point there at the bottom of the slide, hydrogen engines have the cost advantage if you have a low amount of usage per day, because in that case, the capex is more important, and the capex, as I say, is lower for hydrogen engines. But if you have a very high amount of usage per day, then the fuel cost will come to dominate, and therefore, because of efficiency, fuel cells will actually be the better choice. In terms of the companies that are involved in this market, I don't mean, by the way, here to present everyone. So I'm just presenting a sample of some of the companies that are included that are in this market. So Liebherr has produced 2 hydrogen combustion engine prototypes. They were presented there at Bauma recently, and they're targeting series production by 2025. JCB has produced at least 2 hydrogen engine vehicles, one of which was a backhoe loader. Deutz is also active in this area. They have already some projects going. They've already produced hydrogen engines, and they're targeting full production by 2024. And Cummins, of course, as an engine manufacturer, is also involved. And Cummins has signed several letters of intent with future customers, including in trucks and also one in agriculture area. And then finally, I just wanted to mention Bosch, who also presented components for hydrogen engines at Bauma. So I would just like to make the point that I've already talked about it, but I just think it's really important. So I just do a whole slide on this. But basically, the cost of hydrogen fuel is going to be very important. If we see a situation where the cost of hydrogen stays high as it is today, it doesn't really go down at all, or very slowly, then you're just going to see that hydrogen engine vehicles are really not competitive at all. On the other hand, if the price goes down very rapidly, then you could imagine a situation where hydrogen engine vehicles are going to do much better and are going to compete quite nicely with battery electric and diesel. But that would perhaps need to do even better than the $5 in 2030 and under $4 in 2040 that we're forecasting, which is already, I would say, pretty aggressive. So I'm just going to go very quickly through 3 different applications for hydrogen engines: buses, trucks, and off-road. I'll just go very quickly through the buses one because I don't see that as being a strong case for hydrogen engines. Battery electric can do the job, generally better. If you look at cost and environmental considerations together, battery electric will generally beat hydrogen engines. And of course, you know, we're talking about city centres often with buses, so even the small amount of NOx of hydrogen engines could be a problem. Noise may also be a concern. Trucks, in the truck market, TCO is really, really important, and the TCO for hydrogen engines is not as good as it is for diesel and battery electric vehicles, and that will remain the case, as I said earlier, unless hydrogen prices really fall a lot. So some organizations may buy hydrogen engines just to showcase the new technology, but realistically, it's going to be quite a small percentage of the market. That being said, trucks is a very big market, so you can get 1% of the market. That's, you know, still very significant, still very worth having if you're one of the few companies that have this technology. Off-road, in some ways, is better opportunity for hydrogen to find its niche. Now, it is hard to compete with diesel on cost, but of course, diesel won't be around forever, perhaps due to regulations. Now, battery electric will compete well, and already does, for smaller vehicles produced in volume, like forklifts. But where you have large vehicles, where there's just a small number, it's easier to just change the engine and find somewhere to put some tanks, rather than what's sometimes required for a battery electric vehicle, which is a whole redesign of the powertrain and even the shape of the vehicle. So that's one opportunity for hydrogen engines to come in where there's a need for an alternative solution and battery electric vehicles are not available. Another possibility is something that you don't find so much in the on-road market, where just battery electric vehicles are just not fit for purpose. And that's for various reasons. It can be the weight of the batteries and the large size of the machine. But the most important one is just when you have many hours per day. You know, if the vehicle's being used 10, 15 hours per day, then the situation is that the battery's going to run out and it's just not going to work. So hydrogen engine doesn't face that limitation. It can keep working for 10, 15 hours a day for whatever's needed, really. Also, fuel cells in off-road, a little bit trickier in terms of dirt and dust. So again, that helps for hydrogen engines that are thought to do better in this area. And loaders, lift and excavators are some of the vehicles where we have forecast hydrogen engine shipments. So we can see on this graph that we don't forecast much to 2030. So with this being a sort of immature market, we did a more of a long-term forecast, and we forecast most of the shipments to come between 2030 and 2040. So that's when we really see growth. At the moment, it's more, development, prototypes, getting the first customers, getting the market going. So small market to 2030, and then just under, we're forecasting 500,000 in 2040. Of course, a pinch of salt with a forecast to 2040 on a market that's really just getting started and is almost zero today. That's always difficult. But just to give a rough idea of where we see this. Now, of course, in 2040, almost 500,000, it could potentially look like a big number, but it's just worth remembering that this is the total market. So this is the total of all buses, trucks, passenger cars, rail, marine, off-road. So we're talking an order of 100 million vehicles here, and saying that hydrogen engine will get less than 1 million of that. So we're not predicting this market. We're not predicting this product to ever really take off. It's in a big way, it's more likely to be a case of it finding its niche. Okay, so thanks a lot. I hope you found that useful. Please feel free to get in touch with me if you'd like any information about a new report or anything else. Thanks.
Thank you, really good job. Thank you for your insightful point of view. A view that usually emphasizes the ultimate goal of electrification over other intermediate steps on the road to decarbonization. So really thanks. Okay, let me turn to those who their knowledge in the first hydrogen-powered lane wheel application. You can find it in southern Germany. That's Cummins. So everyone knows Cummins. Please, Jimmy Evergood can tell us the Cummins puzzle towards hydrogen from internal combustion engine to fuel cell. Please, Jimmy.
Great, thank you very much. Thanks for hosting today, and I'm happy to be here. So Cummins is a global power leader that operates in 190 countries and territories with 60,000 employees and 103 years of experience in the industry. In 2021, we spent about $1 billion in R&T on multiple technologies. Cummins designs, manufactures, and distributes engines, batteries, fuel cells, electrolyzers, power generation products, and associated components. And we're guided by our Destination Zero strategy, which is focused on well-to-wheel emission reductions that include incremental improvements today across all of our technologies, while investing in technologies for tomorrow, which include battery electric, hydrogen fuel cells, hydrogen internal combustion engines, as well as technology throughout the entire value chain of hydrogen. And we're investing in these different approaches and technologies because it's obvious that the industry needs an array of solutions to truly decarbonize. Diesel is ubiquitous today. It's very low cost, it's highly durable, and it's highly versatile. It can get the job done. And so as we look to the future, we will need different solutions to fully cover what's accomplished today by diesel. And those will include battery electric vehicles, hydrogen fuel cells, hydrogen engines, renewable natural gas, and low carbon diesel. There will not be a single solution that solves all of the problems and meets all of our application needs and customer needs. And so again, we need numerous solutions, which is why we're investing in the hydrogen engine. We see that it's very complementary to fuel cells. The hydrogen internal combustion engine leverages the entire value stream for hydrogen production, distribution, dispensing. And it just gives an alternative, another option to use hydrogen, which we believe will help grow the hydrogen economy. Having two different consumption technologies, fuel cells and engines, just increases the use cases for hydrogen fuel. It also builds scale for components related to hydrogen, like hydrogen fuel storage tanks, onboard fuel technology to store that gaseous or liquid hydrogen. So hydrogen internal combustions we feel like are a great solution. Zero carbon is the key. It's a zero carbon fuel. And when it's compared to other zero carbon technologies, the hydrogen engine is the lowest initial cost. technology. It's the lowest weight and has fast fueling. It's robust to environmental conditions like low ambient conditions or poor air quality. It operates where an engine can operate today. It leverages existing supply chains, which is another really important point for both vehicle components, the chassis, and all the accessories in the vehicle. So that means that engine technology can go relatively fast because we have installed capacity to build conventional powertrains. Also, the hydrogen engine does not compete with light-duty passenger car markets for battery materials. And so we will see an aggressive need for materials to build batteries for light commercial vehicles as well as passenger car in those areas where customers have access to the charging and the conditions are right. And the commercial vehicle and equipment space is a relatively small global player compared to passenger car. So having a technology like hydrogen engines that doesn't compete with that supply chain could be an advantage to help, again, progress decarbonization in our sector. There's also a high degree of familiarity, which is really what I feel like customers are resonating with. It's a conventional technology. They understand how to maintain it, take care of it. It's familiar. It has the durability is known. And that also gives customers a sense of comfort when they move to this technology, because they can move to a powertrain that they understand, and now the complexity is the fuel, and now how do I get fuel, and infrastructure becomes the conversation, but they have a level of comfort with that powertrain. So I'll talk a little bit more about the customer interest in a second, but let me first make a few comments about the fuel. And we are starting to see global support for hydrogen as a commercial fuel. Again, it's that zero carbon element that is so attractive, but it can be used in two consumption technologies, both the fuel cell and the engine. Which again makes that fuel very attractive. The fuel can be produced where there's an abundance of green energy and transported to locations for consumption. That's a harder thing to do with electric because it relies on grid stability and other factors, where hydrogen is a lot like diesel in that it can be produced in one location and moved relatively easily. You can put hydrogen on a ship and ship it across oceans. You can put it on a truck and move it from point A to point B relatively easily. You can move it to remote locations, remote construction sites and farms. It's very similar to diesel. It's not the same, but it has some similarities. And that's harder to do with electrons, to put them on a ship and move them across the world. So there just seems to be a global interest and consensus on hydrogen as a commercial fuel. And so we, again, with this build out of infrastructure, which will take time, there's no doubt the market will be small to start, but as we see a market, the infrastructure develop and fueling develop, we continue to see customer interest in the hydrogen engine technology. We are taking pre-orders for the powertrains and had a number of large fleets announce their interest. And we've also had a number of equipment manufacturers announce their interest in integrating the technology, including Versatile, who's an agriculture tractor manufacturer, as well as recently Tata Motors has signed an MOU with Cummins for our 6.7 liter hydrogen engine for the Indian truck market, which is a low cost market, which is starting their journey to decarbonization. And there's a number of factors in that region which make hydrogen an ideal fuel. And then again, the hydrogen engine, a low cost option for that. So thank you again for the opportunity to talk about hydrogen engines with the group, and I look forward to the discussion.
Thank you very much, Jim. Now it's up to Punch Hydrocells to pick up the baton. You have finalized hydrogen internal combustion engine research in the marine field, as we saw at the Genoa Boat Show, and in power generation at Bauma. And what about off-road applications? Internal combustion engines fueled by hydrogen, present and future as well?
Yes, thanks for hosting and for the opportunity to be part of this very interesting discussion. Let me just share a few words on Punch Hydrocells. So we are part of a Punch group, and we are located in Torino, and we were former General Motors Global Propulsion System Development Center. So we are expert in developing propulsion systems as well now on hydrogen, but for sure we come from a long history of developing diesel engines as well engine controllers. And starting from this our heritage, We developed the hydrogen engine that we presented at Genova, as you said, and at the biomass show in collaboration with Technogen. And we believe that the hydrogen engine is a key technology for off-road application, because as it was said already, we believe that in a harsh environment, this technology can be really strong in comparison to other technologies like batteries. For sure, we are active also on fuel cell technologies and on production, storage, and distribution, as we think that all this technology will be complementary, and we should not look for one single technology when we want to achieve our decarbonization targets.
So, it's okay. So, very short, thank you. Yes, piece by piece, the picture of the mosaic is now clearer. So we are approaching the conclusion, and we would like to the participant, in alphabetical order, how they see hydrogen applied to internal combustion engine in the short term. What is your agenda? And with a straight answer, so I mean basically yes or no, would you bet on the spread of this technology? Just to clarify, I'm asking to comments and pans. Finally, we have a final question for all the 4 panelists. So please, Jim.
All right, if I had to bet on hydrogen engines, absolutely, they're here to stay. There's a really strong market for them. I think, again, we need the technologies. A technology transition is difficult in any new fuel type, no matter how we support it. It is a very difficult journey. And we feel like this practical technology will play a significant role. It'll be slow to start. We'll see volumes probably starting in the early 25s and 26 at small, and then it's really about finding those opportunities to make the technology with customers and fuel. But those opportunities will grow with the build out of infrastructure. We're seeing a lot of movements in a number of regions, and I think the infrastructure will be there, and it'll grow quite fast, probably faster than we've seen natural gas infrastructure because of that government support and industry support.
Okay.
Yes. Absolutely, yes. As well, from Punch's side, we strongly believe in this technology. As a matter of fact, we invested in converting our test cell running on hydrogen, and we invested in our first product that we launched into the market. And we think hydrogen engine will play a key role in the industry, especially in the heavy-duty sector. Yes, and we believe starting from 2024, 2025, this market will accelerate. As of today, we see it as a niche market. We see clients already interested in purchasing the first product. In fact, we sold the very first genset with hydrogen engine to John Fant, a client in UK. So we see really this accelerating. So yes, we believe in this technology.
So perfect. It seems to us to address all panelists, because we are really approaching the final step of this webinar, with a generic question, flexible enough to allow everyone to customize their answer, because we are touching the real crucial point. So how to improve the efficiency and affordability of the hydrogen, because you know, the more you change and you add steps and stages of transformation, more the efficiency of the energy loses. So please, in order, Cummins, FPT, and hydrocells and this NGV and Punch, sorry. Please, Jim, again.
Oh.
No, Jim?
And the question was, how to improve the efficiency of the entire process, right? Oh, that's a big question. That's a really big question. Thanks for asking me to go first on this one. I mean, to me, the biggest efficiencies are supporting the technology from a government perspective, reducing regulations and adding incentives to the fuel and production and distribution of the fuel, and look for opportunities to accelerate that. I think the powertrain technology can come. It's an infrastructure, it's the classic chicken and the egg. And then the more we gain confidence in infrastructure being there, I think the technologies to consume it will come and come at a faster rate.
So, okay, please. The above FPT industrial.
In order to increase hydrogen engine efficiency, direct injection technology is the key. We are already working on this technology on the first concept application of the new XC13 hydrogen combustion engine that we installed on the world's first hydrogen-powered snow groomer developed with our partner, Prino.
NGV Powertrain, not hydrogens.
No problem. No, I think that, okay, for sure, okay, in terms of engine itself, will be matter of working more and more, and for sure there will be some solution that will increase the efficiency of the IC H2 engine. But I think that the one very important point that has to be kept on the completely efficiency is also try to use as much as possible the existing supplier base and the existing technologies and also existing infrastructure, because let's say that any new infrastructure will need to be built with the current technology, so probably creating some other, let's say, extra deficit. So the idea is that a smooth change from current fuel to H2, but trying to use as much as possible the existing infrastructure that at the end are already existing, so they don't need to be invented to build up with existing technology. So at the end will be a faster and probably a wiser way to switch from current to hydrogen.
Okay, finally, plant hydrogens.
Well, yes. First of all, we can say that already today, focusing on ultra lean combustion concept, and with our optimization technique, we achieved an efficiency that it's equal to a state-of-the-art diesel engine using a port fuel injection technology. So the key factor were optimizing the combustion system and the control strategy. And already today, we can show a very high efficiency from an internal combustion engine fueled with hydrogen. We are as well already working on a direct injection technology that it's the next step to further increase the efficiency of this engine. So again, we demonstrated already today that we can achieve an efficiency as we speak, at least similar to a state-of-the-art diesel engine, and we are clear planning to further increase the efficiency working on direct injection technology.
Okay, thank you so much. Before passing the word to my colleague, I said my apology for overlapping and confusing the name, but we are very tired. We are jumping from an exhibition to the other one because it's a very exciting and vibrant time for our environment. For instance, but I guess tomorrow morning we'll leave very early in the morning for landing to Amsterdam for attending the Mets. So thank you so much. Please, my ragazzi.
Okay. On behalf of Powertrain International, I sincerely thank all of you who followed us, and especially the panelists, Jim Nebergold, Cummins, Andrea Abba, FPT Industrial, Jamie Fox, Interact Analysis, Fausto Elementi, NGV Powertrain, and Roberto Golisano for Punch Hydrocells. Decarbonization is as urgent and imperative as it is complex. You certainly can deal it with a magic wand. You have helped us to deepen these topics. All the more reason to thank you all again and say goodbye to you in view of the Sustainable Powertrain Tour 2023. Ciao.
Ciao is an international greetings. Hi everybody. Thank you so much.
Thank you for the opportunity. Thank you for the opportunity.